Saxon Algebra 2, lesson 111, da 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 da. It's a lovely number. And so you know it's going to be a good lesson, and it is. What we're doing today is word problems. Oh, don't be sad. We're doing word problems that have, so that it'll be a system of equations. The situations will be familiar, but there will be three equations, three statements of things that are equal that we will use to build the equations, and then we'll solve them. Compared to some of the three-part system of equations that we've been working without word problems, they're not as crazy as some of the things we've been doing. So most students find that the word problem part is challenging, but they're familiar scenarios, like we're going to start with a coin problem. And the statement, the equations that we generate are relatively easy to cope with. So I hope I've psyched you up. Example 111.1. Don't you wish there were 11 examples in this lesson so we could go all the way up to 111.11? I do. I'm sure you do too. Okay, ready? It's a coin problem. And what I want to point out to you before I read it is, listen, there will be, remember how we've had quantity statements and then we have value statements, and then there's one more. That's the way these usually work. Is there's a clear quantity statement, a clear value statement, and then one more. Okay, we'll listen to it. It's really dark in this room. There were 26 nickels, dimes, and quarters in all. All right. I feel a quantity statement coming on before we even go any further. The number of nickels plus the number of dimes plus the number of quarters equals 26. Right? We're used to doing two of the three. That's not that hard. And their value was $2.25. Okay, we remember how this works, right? You have to multiply each coin by how many cents it's worth. 5 times the number of nickels. Dimes are worth 10 cents. 10 times the number of dimes plus 25 times the number of quarters equals $2.25, but we're going to drop the decimal out of there because we're stating this as cents, not dollars. Okay, beautiful. So far, so good. How many of each type were there if there were 10 times as many nickels as quarters? Okay, this is where everybody gets confused because 10 times as many nickels as quarters makes you think, oh, 10 nickels equals quarters. No, that's not right. There's 10 times as many nickels as quarters. That means the number of nickels is greater than the number of quarters, right? Let me read it one more time. There were 10 times as many nickels as quarters. So this is why it's confusing. There's 10 times as many nickels. So that means in order to make them equal, we have to multiply this side by 10. Not this side. This is the side that there are already more of. We have to multiply this one by 10 to get it to balance. And if we write it as an inequality first, it's so much easier to see that. We know that there are more nickels than there are quarters, so this is the one we have to multiply by 10. I'm going to put parentheses around it and write it here just because I don't want to try and squeeze it in there. Now they're equal. Dig it? It's cool, right? You can do this. Okay, beautiful. So now we have our system of three equations. I'm going to put my little thing here so I don't squish everything. And now we're ready to just figure out how to substitute all of this in. Now, there's, of course, many ways you can play this game, but this is the easiest way that I think there is to do it. Let's take this, number of nickels equals that, and let's plug it in here, and let's plug it in here. Okay? So the first equation is going to become 10 times the number of quarters plus, I just want to make sure I wrote that right. It was quarters. Yes. 10 times the number of quarters equals the number of nickels, so I'm changing that. Plus the number of dimes plus the number of quarters equals 26. And now before I go on, I'm going to add like terms, and I'm going to say the number of dimes plus plus 11 times the number of quarters equals 26. Okay, so there's one good equation. We'll come back to that. Now I'm going to fix this one. Okay, 5 times 10 times the number of quarters plus 10 times the number of dimes plus 25 times the number of quarters equals 225. All right. Beautiful. Now we will multiply, well, let's just do that quickly. That's 50 times the number of quarters, right? And we'll combine this and this. So it will be 10 times the number of dimes plus, this we multiplied and we got 50 plus 25, 75 times the number of quarters equals 225. How do you feel about it so far? It's kind of crazy, right? Okay, but it's perfect. Okay, so now we're comparing these two. Okay, so we have options again. We could rearrange this one to the number of dimes, and we like by subtracting the 11 times the number of quarters, and we could substitute that in. Or what I'm going to do is let's eliminate. Let's multiply this top row by minus 10. And then it will cancel the number of dimes. All right, so I'm going to multiply this and write it down here. Minus 10 times all three pieces. Minus 10 times the number of dimes. Minus 110 times the number of quarters equals minus 260. Okay, so I multiplied that times that. Now my D's will cancel. Now I'm comparing these two, right? This cancels. This will be what? Negative 35 times the number of quarters equals, shoot, look at that, negative 35. So when we divide, the number of quarters equals 1. Are you even kidding me right now? Where should I write this? Over here. Okay, I'm going to write number of nickels, number of dimes, excuse me, number of quarters equals 1. That's the right answer. Isn't that cute? Huh. Okay. So now we go back. I like to look at the original equations because they're usually in the simpler form. Is there anything we can do here to solve another one easily? And I look at this third one and I say, okay, I know the number of quarters. It's 1. So if I multiply that by 10, that gives me the number of nickels. That's got to be 10. Right? I don't even have to write that down. I could if I wanted, but I feel pretty confident doing that one in my head. And then same here. We know that all three of them have to add up to 26, and I've got 11. So this has to be 15. And we can double check that really easily. That's 26. So that checks. So this is what I think my answer is. And I'm right. Even though this is a system of equations, we don't have to write our answer as an ordered triple because it's a word problem. So it makes more sense to present it in this fashion. Here, let me scoot it up so you can see it. Makes sense? Yeah, it's kind of dark down there at the bottom of my page. Okay. I hope you can see it. I mean, we're a whole year into this, and now I'm worried about whether you can see my writing. Huh. Okay, more lights in this room just went off. I'll be teaching by Braille soon. Okay, we just have one more example. And it works in a very similar way. And so I'm just going to write this down. A quantity statement, a value statement, and then one more. That's usually an inequality and we have to be really careful with. All right. The total number of blues, greens, and yellows in the pot was 7. All right, blues, greens, and yellows. The number of blues plus the number of greens plus the number of yellers equals 7. That's not very many. Okay. Now, we don't know what these things are, but given the next piece of information, my guess is bowling balls. The blues weighed 1 pound each. The greens weighed 4 pounds each, and the yellows weighed 5 pounds each. The total weight was 25 pounds. Okay, so these bowling balls don't have value like coins, but they can be valued by their weight, right? So the weight of the blues is 1, so I'm just going to write that there. I don't really need to. The greens weighed 4 pounds each, and the yellows weighed 5 pounds each. And the total weight was 25 pounds. Okay, so there's a value statement. Now we're just looking for one more. If there was one more yellow than green, okay, there's one more yellow than green. That means the number of yellows is greater than the number of greens. It's so important, you guys. Write the inequality first. It'll be so much easier. There was one more yellow than green, so we add 1 to the greens to get them to be the same. How many of each were there? Okay, we're ready to go, right? This is our fabulous system. I like to put the parentheses around it because it kind of reminds me of what we're doing. We're solving all of these together. Okay, I'm going to do the same thing I did before because I thought that was really fun. I'm going to take this one that's all set up for substitution, and I'm going to substitute it in here, and I'm going to substitute it in there. All right, and this is what's going in. So let's redo the first one. The number of blues plus the number of greens plus beep, 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 this thing. Number of greens plus 1. I could put parentheses around that because I'm bucketing it in, but there's just plus signs for days, so I'm not too worried about it. So I'm just going to leave it as is. It's equals 7. And then I think what I'd like to do is I'd like to combine these like terms, and then I'm going to subtract 1 to clean this equation up. So the number of blues plus 2 times the number of greens equals 6. Okay? And now we have to do the same thing. Here's one of my equations. I'm going to put an arrow to it. Last time I squiggled it. That helps me find it when I'm looking for it again. Now we're going to do the same thing with this one. I don't need that 1 there. I'm going to drop that. The number of blues plus 4 times the number of greens plus 5 times, not NY, but this thing, number of greens plus 1, equals 25. All right, we'll distribute, and I'm just going to write it here, 5NG plus 5. Now I can add like terms. This and this will go together, and I'll subtract 5. Get that number out of my way. Number of blues plus 9 times the number of greens equals, okay, that canceled too, equals 20. Feel good about that? Okay. Crossing these things off. Did you guys know Natalie Smith? I hope you know Natalie Smith. She is a freaking caution. I taught Natalie for many years, but if I didn't cross them off, of course we were sitting together. It wasn't in the land before COVID, and we actually sat together at her dining room table before she moved to Texas. And if I didn't cross these off, she would literally just take the pen out of my hand and reach over and cross them off for me and then hand me the pen back because it drove her crazy if I didn't cross them off. Okay. That's looking pretty good, isn't it? That's looking real good. Let's figure out what to do now. We have to eliminate these two. At least that's the way I want to do it. We could always set this up to substitute again, but I like to eliminate now. I think we should multiply one of these by -1 and get these NBs to cancel. The NGs have different numbers, but the NBs are exactly the same. This is the 6, and that's 20. I would rather come up with a positive number, so I'm going to choose to multiply this one by -1. All right, so I'm going to rewrite it down here. Minus NB minus 2NG equals -6. All right, so that is there. Now we're ready to add. Natalie Smith, 7NG equals 14. Aw, thanks, John. I'm going to make my list for my answers over here. The number of blues, the number of greens, and the number of yellows. I like to keep them in the original order. That just helps me feel organized. Crossing off, the number of greens equals 2. Okay, I always like to just take a minute and just like be happy. I checked that solution. And I do suggest you guys in problems like this, go ahead and check at that point and make sure you're good. And now, but don't look at the other answers if you can resist it. Okay, now I'm gonna go figure out what else I can do easily. Oh, I like this. Number of greens plus 1 is the number of yellows. So that would be 3, right? Number of yellows is 3. And then they all have to add up to 7, 5, 6, 7. So this has to be 2 as well. That adds up to 7. I like that. It's a good way to check your answer. And blue 2, yellow 3, greens 2. Yay! You see what I'm saying? These are a little crazy and we have to sort out the words, but actually solving these was pretty straightforward, right? We just substituted into both and then eliminated. All right, I hope you feel smart. I hope you feel like these are not that big of a deal. Lesson 111 is history. Thank you. Goodbye.